Hello student, today I have brought a video on the topic Newton's law of motion of chapter 9 physics of class 9. Last video we had discussed about the force and effect of force and different types of force: mechanical force, gravitational force, electrical force. With type of force we will discuss in the last video. We will also discuss about the unbalanced force and balanced force and the resultant force. And elementary idea was also given for the Galileo's inclined plane and the inertia. That will be discussed in detail in this video. So we first discuss about what is the Galileo's inclined plane. Galileo's expression of motion of an object on inclined plane, that is given in this slide. Here, look here. It is the experiment. Here Galileo has made two inclined, left side and right side, and a ball is allowed to move from the left side of the inclined plane, and it moves up on the right side of plane, and gradually the inclination of right side is reduced and made it is horizontal, and he expected that the ball will continuously move on the horizontal plane if there is a frictionless floor that has no friction, zero friction. And this Galileo expect and formulated the laws of inertia. We will discuss about in detail that Galileo's expression how and what he concluded from the experiment. Here, when a marble rolled down an inclined plane, it is the inclined plane that is the experimented by the Galileo. Its velocity increases, and when it goes up on the second inclined plane, its velocity decreases. If the inclinations of the ball, both the plane are equal, then the marble will reach the same height with it rolled down. If the inclination of the second plane is decreases, it will travel more distances to reach the original height, like that. Here the inclination gradual, and so the first inclination the ball travels shorter distance and achieve the height of the initial position of the ball. In the second inclination, the ball covered more distance to reach the height of the initial height of the ball, and the inclination again reduces, and the ball cover more distances to achieve the height of the initial position of the ball. And when the inclination of the ball is made right hand side make 0, that is the horizontal, the ball will continue to move forever. That is expected by the Galileo, that by the experiment he formulated like that, and travels more distances to reach the original height. If the inclination of the second plane, that is the right side plane, made horizontal, like that, the marble will travel forever trying to reach the same height. This height is when the inclination plane is horizontal, the ball will never achieve the height of the original height, so the ball will continuously moving on this horizontal plane. The marble will travel forever trying to reach the same height, and unbalanced force is required to change the motion. It is expected by the Galileo. The unbalanced force is required to change the motion of the marble, but no force is needed to sustain the uniform motion of the marble. That means there is no external force required when an object is moving to sustain the velocity. Due to the frictional force of floor, due to the frictional force of air, the ball and reduce their velocity, so to maintain their velocity external force is required. But when there is a fractionless floor and there is no friction, zero friction, the velocity that once acquired is remain forever, and there is no another force required to sustain the velocity. That is guessed by the Galileo. And this tendency to remain at rest or remain at motion is the natural tendency of an object called inertia, and the concept of inertia is formulated and drawn on the basis of the experiment. Now, in detail, how the Newtons formulated the first law of motion with the idea of this experiment. It is given here. Look here. Newton's first law of motion. Newton's first law of motion is nothing but the explanation of inertia. An object will not change its motion unless acted on by an unbalanced force, external unbalanced force. That means if it is at rest, it will stay at rest. If it is in motion, it will remain at the same velocity. That means the object has natural tendency to remain its rest of position, rest of state, and the state of motion. That is the natural tendency of the object known as inertia. Now look here. Object, how the inertia is measured. Object with greater mass. Here the two massive object, here 300 kg of object, ball here 30 kg. Obviously 300 kg is more mass, and then the 30 kg of ball. So it has greater mass, so it has required more force to move the ball. So due to the more inertia of rest. So we can say that the mass is the measure of inertia, and whether it is rest, whether it is motion, or whether it is in direction. Now look here. Here we are going to discuss about next slide. What is the mass and inertia correlated? Look here. The more mass of an object has, greater inertia, and the more force it takes to change its state of motion. That is given in the previous slide, that the 300 kg of ball has more inertia as compared to the 30 kg of ball, because a great amount of force is required to move the 300 kg of ball. Mass, so we can say that the mass is the measure of inertia of an object, and the amount of inertia of an object has depends on its mass. So the inertia can be measured by its mass. Now, next slide we will discuss about the laws of motion that is formulated by the ideas of Galileo. Newton's formulated three laws, and the first law, second law, and third law of Newton's law of motion. Now first law of motion nothing but a explanation of inertia. So it is also called law of inertia. And what is it? An object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an unbalanced force. Second law of motion is stated that it is the definition of force. It is also known as the law of acceleration. When force is applied on a body, acceleration is produced. How the acceleration is measured, it is given by the second law. So in this second law, we also derive the expression for force, that is force is equal to ma, mass into acceleration. Now third law, it is also known as a law of interaction. When two bodies comes together and contact force is applied with another body, then it is measured by the third law of motion. Now, for every action, there is an equal and opposite reaction, that is the third law of motion. That will be discussed in the next video, but in the two laws, first law of motion and second law of motion, discussed in this video. Now, again we discuss about the first law of motion, also known as law of inertia. A moving object moves in a straight line with constant speed unless a force acts on it. That is the motion of inertia. The tendency of an object at rest to remain at rest and an object in motion to remain in motion unless acted upon by an unbalanced force. That is the law of inertia, and this is given according to the first law of motion. Next, we will discuss about the type of inertia. How many types of inertia? Inertia of, that is the inertia of rest. First, inertia of rest. In it, a body cannot change its state of rest by itself. When a body is rest, it remains rest unless an unbalanced force acted upon it. That is known as rest of inertia. Inertia of motion. In it, a body cannot change its state of motion by itself, and it changes motion when unbalanced force acted upon it. But if there is no unbalanced force, the object is moved forever. That is due to the motion of inertia. Inertia of direction. It is the body cannot change its direction. When the body is moving in a certain direction, it opposed to change the direction, and due to the direction of inertia, that will known as the inertia of motion, inertia of direction, on its own moving in the uniform motion. That is the types of inertia. One by one we will discuss again about it. Now, what is the rest of inertia of rest? The natural tendency. It is the natural tendency of your body. It is the natural tendency of your body to oppose any change in its state of rest is known as inertia of rest. It is given. Example: when a tree is vigorously shaken, some of the leaves fall from the tree due to the rest of inertia. When a tree is vigorously shaken, then the branches of the tree becomes in motion, but the leaves tends to remain in the rest due to the inertia of rest of the leaves fall down from its tree due to the rest of inertia. Now, again, we will discuss about when a tree vigorously shaken, the branches of the tree come in motion, but the leaves tends to continue in their state of rest due to the inertia of rest. As a result of this, leaves get separated from the branches and tree and hence fall down. That is due to the rest of inertia of rest. Now, next slide we will discuss about example of inertia of rest in daily life. When a cardboard is flicked, here the cardboard and a tumbler and glass tumbler, and it is a cardboard and a coin is kept on it. When the cardboard is flicked, the coin falls into the glass. This is because the inertia of coin maintains the state of rest and it falls into the glass. If cardboard is drawn from the side, then the coins fall down on the glass due to the rest of inertia. Now, inertia, second type of inertia, inertia of motion. It is the natural tendency of a body to oppose any change in its state of uniform motion. Is known as inertia of motion. Example: the passenger fall forward when a fast moving bus stops suddenly. This is because the lower part of the body of the passenger comes to rest as soon as brakes as soon as the brake applied and bus stops. But the upper part of the body continue to move forward due to the inertia of motion. So the passenger gate is jerked forward. That is due to the motion of inertia. Next is various example of inertia of motion. Some example of inertia of motion is given here. A person trying to get down from a running bus fall forward. When a person trying to get down from a running bus or train and they fall forward. Explanation is that when the person gets down from a running bus, the upper part of his body is still in motion, and due to this inertia of the motion, the body toppers forward even though it rests on the foot on the ground. Next, passenger traveling by the train falls forward when the train applies sudden brake. The explanation is that due to the inertia of motion, the motion of all the passengers is equal to the motion of the train, and as soon as the brake is applied, the passenger's feet being in contact with the train floor stops, while the upper part of the falls forward due to the inertia of motion. Ripened fruits fall down on the tree in the direction of wind. The incident in our daily life is due to the motion of inertia that we'll discuss in this slide. Next slide, we will discuss about the inertia of direction. The natural tendency of your body to oppose any change. Its direction of motion. Direction of motion is known as inertia of direction. Example: when a fast moving bus negotiated a curve on a road, passengers fall towards the center of the curve path. This is due to the tendency of the passenger to continue to move in the straight line, and the passenger fall forward direction due to some other direction due to the inertia of direction. Now, the first law of motion gives the explanation of inertia, and various types of inertia we discussed previously. Now I am going to discuss about the second law of motion, but to understand the second law of motion, we should understand it very important term known as the linear movement. It is called also linear momentum, only movement. Momentum is the measure of inertia. The momentum is also the measure of inertia. It is related to the mass in the motion. Momentum is equal to the mass multiplied velocity. When the mass is multiplied velocity, we get another types of physical quantity known as linear movement. Now, the movement can be written P is equal to mv. M is the mass of the object, V is the velocity of the object. Now, next slide we discuss about Newton's second law of motion. First law of motion give the ideas of inertia and the explanation of inertia. We will discuss in the previous slide. Now, it is the second law of motion given here. Newton's second law of motion in the term of the momentum. Newton's second law of motion stated that the rate of change of momentum is directly proportional to the force applied in the direction of force. For example, when acceleration is applied on a moving vehicle, the momentum of the vehicle increases, and the increase in the direction of the motion because the force is being applied in the direction of the motion. On the other hand, when brake is applied on the moving vehicles, the momentum of the vehicle decreases and decreases in the opposite direction of the motion because the force has been applied in the opposite direction of the motion. And we can say that when a force is applied, how the force is measured, it is given by the second law of motion. Now, how the force is measured, it is the rate of change of momentum that is given in the formula, and we also derive the formula derivation for F is equal to ma, that is the second law of motion, related to the second law of motion. Now look here. Here, according to second law of motion, the rate of change of moment, what is the rate of change of moment? It will be momentum here v into mv minus mu. Here you can also say that the momentum rate of first the change of momentum like that. Change of momentum is equal to mv minus mu, and which is divided by t, we get the rate of change of momentum. Now look here. The rate of change of momentum m v minus u by t. Here, according to the Newton's second law of motion, we have the F is directly proportional to the rate of change of moment, and F is equal to K m vu by t. Vu by t, according to the first equation of motion, v minus u by t is equal to a. If you put the value of a here, we get F is equal to K ma, where K is the constant of proportionality. K is the constant of proportionality. Proportionality. It is the constant key. It is constant. Now look here. When F is equal to Kma, then here A is equal to v minus u, the rate of change of velocity, and look here is the acceleration. Then here K is a constant of the proportionality. Putting m is equal to 1 kg. You have m is equal to 1 kg, that is the SI unit of mass, and A is 1 meter per second, that is SI unit of A, and F become 1 Newton. When everything is taken here, putting mass is equal to 1 kg, acceleration is equal to 1 meter per second, and then F becomes 1 Newton. 1 Newton is equal to K into 1 kg into 1 meter second square. Here K is equal to 1. That is the constant of proportionality is 1 here. From the equation, first we get a F is equal to ma. This represents the second law of motion that is given in the video. We can see that the force is equal to, applied force is equal to ma. It is the mass of a body, and A is produced on a, when force is applied in a body, acceleration is produced, and force is directly proportional to its mass. Acceleration is directly proportional to the mass. Here we can also like that. Force is the product of mass into acceleration. And we again discuss about how the acceleration of force is related and mass is related. Okay, we will discuss in the next video. Thank you.